which model we have to choose, and what will be the requirements while we choosing a model. Time to roll up our sleeves and get practical. To implement instruction fine-tuning, we are using the PET library from the Hugging Face ecosystem. We are also tapping into QLoRa like quantization as the quantization mechanism for memory efficient fine-tuning. Why you are using LoRa as lower rank adaptation technique as the lower rank adaptation technique and quantization techniques here. It's all about efficiency, not overburdening. Like we tried not to overburden our resources during fine tuning. We are focusing on the quantized variant of the model by using lower rank adaptation technique to fine tune components. It's hello everyone. So for now, let's get deep dive into the world of instruction fine-tuning, which comes after the pre-training and fine-tuning, as their core concept is also discussed in details in previous lectures. So we will move directly towards instruction fine-tuning that we will discuss in details in further slides for LLMs. If you want to know about pre-training and fine-tuning session, then you can watch the previous lectures as well. Now moving towards prerequisites and details. But first, let's make sure we are all on the same page. To understand this whole process of fine-tuning and pre-training, you need to know you have some capabilities. You need to have some capabilities like familiarity with Python programming, some basic understandings of NLP, machine learning, pre-training, fine-tuning, and LLMs concepts. Also, a good grasp of data handling as well as features handling everything. Also, our objectives are pretty clear. We will discover why language models need instruction fine-tuning. You will get to know about the large language models architecture usage. Furthermore, we will explore various strategies to perform the fine-tuning in LLMs with their impact and limitations. Now moving towards agenda. Welcome to the roadmap of our whole adventure, which we will do in this whole journey of fine-tuning, pre-training, and instruction-based fine-tuning process. Here's what we are going to cover. These are our concepts, starting from introduction to why we need them, and next each and every step with explanation step by step. Then we have our introduction of instruction fine-tuning by our side. Let's dive into the concept of instruction fine-tuning in large language models. Imagine taking a pre-trained language models is a bit like a versatile musician and defining it for a specific task. This will be done by providing the model with targeted instructions or examples. What's fascinating here is that the process enables the model to fine-tune its abilities to produce precise results. Like, here's the magic. While it becomes adapt to the task, the model still retains its original understanding of pre-training. Like in instruction fine-tuning, each and everything is will be done by the process of instruction. Like the in pre-training and fine-tuning process, each and everything it will be done by the training, and each and everything which will be done by done in the session of training and fine-tuning session needs to be instruct in that in terms of instruction fine-tuning. Like you have to give some prompts to the LLM models, and then that large language models have to work by understanding these instruction, these prompts, and then try to generate some output for you. Like we try to tune a musical instrument to create a specific melody. Even it even if it becomes specialized in generating particular tunes, the initial requirements are still remains the same. Like even you have to give some instructions to the musical instrument as well. Only then that instrument will be able to give some output to you. Okay. In the same way, instruction fine-tuning, in the same way, instruction fine-tuning empowers large language models to excel in specific tasks while while keeping their while keeping their broader language understanding intact. So the overall means of instruction fine tuning is that you have to give some instructions and guidelines to the LLM models. Only then the model is able to train and fine tune the process of whole text generation, summarization, each and everything with large language models. Then why we bother with all the instruction based fine tuning stuff when we have why we bother all this kind of instruction fine tuning or pre-training and fine tuning stuff when we have simple fine tuning concepts, when it's like taking a generic tool and making it perfect for a specific job. By tailoring responses to the intended task, we are making models more accurate and contextually relevant. Here are the key points, like the reasons behind all of this working process, why we do it. Starting from task relevance, like we try to customize it for specific tasks. That will be possible only with the specific instructions. Okay. Then we have some contextual understanding, like we are trying to make responses to be context rich and then fit perfectly in LLMs. Then we have some enhanced performance. In this purpose, we try to give some booster shot type performance in some domains. Then we have data efficiency, try to utilize or use existing pre-trained knowledge so that we can do the current task. Like when wheel is like we know when wheel is already discovered, then we will waste our time to rebuild it. We just try to make sure that wheel is properly working in the car, not to make sure that wheel is properly peeled up, wheel is properly something like that. Resource efficient. Then we have in last resource efficiency, like we try to maximize our resources. So in this overall steps, we try to make sure that why we need fine tuning, instruction based fine tuning in LLMs. Then we have different types of fine tuning. It's not a one size that fits all game in instruction fine tuning. We have a variety of approaches for that purpose. Starting from multitask, in multitask fine tuning for it it's like we require instruction based fine tuning for multiple tasks at a time, at a single time, at different variations of time. It depends. Then we have customized prompts. In customized prompts, we try to craft prompts to guide models. Then pattern learning. In pattern learning, teaching models, we try to teach models to generate patterns. Then we have control content generation. In that, we try to tweak content style. Then we have scenario specific. In the scenario specific type of instruction fine tuning, we try to get models ready for specific scenarios, for getting specific scenarios. And as you can see through that diagram as well, in that diagram, this whole process also help us to understand that we have to give some instruction command as well as when we try to work on a whole document instead of a single prompt, instead of a single paragraph or single word or single line completion, we can give some instructions to the document completion as well, document embedding by giving them chunks of the whole document and try to generate some synthetic responses through that whole process as well as per our requirement. And then we have instruction fine tuning details. Like now let's talk about the heart of the process. In instruction fine tuning, there are three parts: instruction, exemplar, and label. As the whole instruction fine tuning, which we say instruct FT, depends on only these three type of methods. Instruction, but we can give it to through instruction, like instruction fine tuning. Instruction play a role like it sets the path of the model that it will take. And then we have exemplar. Exemplar guides the model's learning journey by giving some example scenarios with expressions. And then we have labels. In labels, we have some add colors to the translation process. In terms of negative, it shows that your label is irrelevant. It's like the LLM try to generate some irrelevant response. If that label is green, it means that your instruction works properly, and the LLM try to generate the most relevant and best possible response against your instruction and exemplar method. It's like sculpting a masterpiece by following a well thought out plan, which will be also done with the help of chain of thought methods that we will discuss in further slides of prompt engineering and techniques and strategies. And then we have some examining features. Now imagine you are testing a fine-tuned model like ChatGPT. Let's say we are using a flipped label ICL prompt. If we have learned content A and input ICL content B, which content will be paid? Will the model adapt to the new context or show a contrast in response? It's like you have to go deep to learn about these inputs and prompt mechanisms. Think of flipped label ICL as a way like we try to force models to go there to let go there of to let go of their initial knowledge and adapt to next context, new context, next context. Then there is SQL ICL. These are labels which we mostly used to instruction, which we try to use mostly in instruction fine tuning or instruction type of label fine tuning, where models must learn about the input label. In SQL ICL, models must learn about is the placement where models must learn about the label mapping, like about those mappings that acts as natural language labels that are no longer reliable. It's like guiding a model to think out to think about a model. It's uh, it's like uh, it's like you have to think outside the box prior to the limitation to adapt something new relevant to the semantics. Okay. If you want to know in detail about flipped label ICL, what is flipped label ICL and what is SQL ICL, you can click on these two labels in the slides and you will directly go to the relevant detailed pages, detailed blogs regarding these two labels as well. If you want to discuss of these two labels. And then we have model instruction fine tuning. So here we will discuss about the curiosity level of the mindset at Harvard and Google that try to do some experiments with the instruction fine tuning. Like they don't like to be sit idle, as we know very well, and look after the innovations in LLMs without further testing them and find something new. Like here, they try to test the models like GPT-3, Instruct GPT, Codex, PaLM, and Flan Palm based on the flipped label ICL, as we discussed about flipped label ICL in previous slide, and try to generate some LLMs instructions and evaluation mechanism that are visible in diagrams with an example about the sentiment analysis in NLP. As you can see through the second approach, second diagram, which shows as an example of 7 NLP tasks based on sentiment analysis, some sentence classification, some are based on question classification, duplication, recognition concepts. These are all different types of evaluation features. Like these are all about the links, the dates. When they try to test instruction fine tuning against these 7 types of sentiments, these 7 types of tasks, and try to generate some outputs like output models, which is visible through the diagram 1, as we have multiple type of LLM models regarding this matter. And in each and every model, they try to test some fine tuning tasks, test some instructions against these large language models. It's like pitting these models against each other to see how well they adapt with each other. Okay. And then we have some evaluation. In evaluation, bigger parts, in evaluation, we will discuss about bigger models. are like bigger models like large LLMs are like they seem to be have an upper hand in overriding semantic meanings when faced with flipped label ICL. This indicates that larger models can easily adapt and learn new content by shifting the balance of responses. It's like watching these models evolve before your eyes based on each factor. We discuss already in instruction fine-tuning and the type of it will with evaluation details in our previous slide. Also, you can see the flip labels against palm models, Codex, Instruction GPT, Instruct GPT, and GPT-3 with their regardings large language models based on 540 billion, as you can see through the diagram of palm that is based on 540 billion, 62 billion as well 8 billion random models. Also in some other text-based models, some other code-based models, post-generating models, all of these models vary depends upon their instruction types, each and everything regarding the matter. And then we have instruction fine-tuning steps, like how we will do instruction fine-tuning or what kind of steps are included in this whole process. All right, that all right. Uh, let's get down to the nuts and bolts of instruction fine-tuning. There are several steps involved in adapting a pre-trained model for specific tasks. It's a journey that involves dataset preparation, prompt engineering, fine-tuning, hyperparameter fine-tuning, and ethical consideration. All of these will be discussed by us in the relevant topics discussion. We already done some discussion about the fine-tuning process, pre-training process in the previous lecture. You can see that as well. It's like you trying to bake a cake where you need the right ingredients and you need a careful process to get the whole cake a fine-tuned output. Similarly, you can see through the diagram as well, where we try to pass some prompts, some prompt-based data set, some instructions to the large language model while training, fine-tuning, and pre-training process. And the large language and then the large language model try to complete this whole process in training and give us some labeled output in in after the whole completion of the process based on these prompt instructions like this like whenever you try to give some properly fine-tuned prompt to the large language models, even you can pass to GPT as well, only then you're able to get the most relevant and best possible output regarding the method you want to search, you want to answer against the particular question you asked to chat GPT. And then we have and now we will move towards the implementation, like which model we have to choose and what will be the requirements while we choosing a model. Time to roll up our sleeves and get practical. To implement instruction fine-tuning, we are using the PEFT library from the Hugging Face ecosystem. We are also tapping into QLoRa like quantization as the quantization mechanism for memory efficient fine-tuning. About QLoRa, we will discuss it with details in further lectures. The Falcon Guanpo is a 7 billion model. Large language models is a star for this whole implementation, ready to take the first step. But before that, I want to highlight the data samples availability in the model logs. Like there are almost 9,476 data samples available in datasets in the Hugging Face models, like playgrounds and the model codes. And then we have quantization and configuration. Why we are using as we already discussed about QLoRa, why you are using LoRa as lower rank adaptation technique, as the lower rank adaptation technique and quantization techniques here. It's all about efficiency, not overburdening. Like we tried not to overburden our resources during fine tuning. We are focusing on the quantized variant of the model by using low rank adaptation technique to fine tune components. It's like optimizing the process to save both time and energy. As you can see through the example of two different models based on the parameter differences, like one is very higher in size and the other is lower in size components, but both can perform the similar task, and even sometimes the small one will do it efficiently due to low parameters and temperature components for smooth conversations. So that's all. Then we will move towards training. Like how we will do is training in the instruction fine tuning session. Let's get towards the training part where we are setting up the default tokenizer tokenizer by using token by token by using SFT trainer as the training components from the TRL library. If you want to learn SFT about SFT trainer as what are the details about this particular training library, you can click on that SFT trainer in our slide and you will able to get to the particular blog regarding this particular library details. But remember, before we start, we have to be specify the training arguments and optimize them for stable training. The process might take a while, like it might take almost 3 to 4 hours. That totally depends upon the model components like we discussed in the training requirements modules. But remember, every hard work will come with a great opportunity. Same, it's like watching a masterpiece come to life. Also, I try to provide a collab notebook link here for the implementation of the instruction fine-tuning process. Like you can go to that particular notebook and you can check how the training process work, how the fine-tuning process work, and pre-training each and every step in detail regarding the instruction fine-tuning, pre-training, and fine-tuning process in this notebook, in this particular notebook. And then we have some challenges. As with any journey we try to cover in LLM modules, there are multiple challenges will come that you have to be tackled to generate a good LLM model. For every purpose, like we try to discuss one by one here, during instruction fine-tuning, we might face issues like data quality, model selection, overfitting, biasness, fairness, data augmentation, transfer learning, each and every type of challenges we are able to face during instruction fine-tuning will be discussed here, will be mentioned here, are mentioned here. And then we have some applications in instruction fine-tuning. Let's find its place in various fields. Okay, from customer, here we will discuss applications which will help the customer support chatbots to medical diagnosis. Start from medical diagnosis to legal document analysis, content generation, and educational support. As these are all type of applications where we try to utilize our instruction fine-tuning mechanism in any kind of large language models, like large language models which can be utilized for various purposes like educational support, customer support, medical, each and everything regarding the large language models requirement. And there we have it, the grand finale. Through careful learning and execution, we will discuss overall details of instruction fine-tuning in conclusion. Like instruction fine-tuning transforms language models from generic to specialized. As technology evolves, fine-tuning will continue to evolve too. It's like a journey that never stops, always adapting to, we try to always adapt to new challenges and advancements. So that's all from my side. Thank you so much.